Hi everyone, and welcome to section 1.9 in Precalculus, inverse functions. Be excited, this is the last section in chapter 1. So we've made a little progress this year. We're almost at the end of the chapter 1. The inverse of f of x, which is denoted, it has a little f and then there's a little -1 superscript of x, is created by switching x and y. Make sure that you pronounce this correctly. This notation is read F inverse. So we're going to study inverses in 3 ways. The first is if you're given a set of ordered pairs, all you have to do is switch all the x values and all the y values. So looking down at number 1 here, if I were going to say F inverse of x, then now all of a sudden it would be 2, 0, -4, 3, and 5, -1. It's that easy. The inverse is literally just f and y, x and y switched places. Second way that we're going to study inverses is given an equation. First, you switch x and y. That step is always going to be the same. But then second, you do need to solve for y. And now we'll do number 2 as our example. So it says to switch x and y, but there is no y. So sometimes there's an extra step. You might have to rewrite it with a y is equal to. So step 1 is to switch x and y. Going too fast for myself. Switch x and y. So now I have x is equal to the cube root of y plus 1. Step 2 is to get y alone. So the way to undo a cube root is to cube something. So I'm going to cube this side, and I'm going to cube this side, and that gives me x cubed is equal to y plus 1. So y is equal to x cubed minus 1. Now there is a third step here. You need to write it as f inverse. You can't just leave it as y because y wasn't in the original equation. We don't want y, we want f inverse. So that should be the answer that you box. F inverse is x cubed minus 1. The third way that we're going to be studying inverses is if we're given a graph. Then you can just pick points and replot each one of them with the x and the y, again, switched. The graph of f inverse will be a reflection over the line y is equal to x. So if you draw that as a dashed line, then you can check your work. So I highly recommend that you draw it. And now we'll do one of those examples. So this graph is going to be a square root function that's moved to the right 3 and down 2. I'm going to pretend, right 3 and down 2, that is my new 0, 0. And then I'm going to literally plot the points that I've memorized or on my appendix if I'm in CP. 0, 0, 1, 1, 4, 2. Those are your square root points. So from here, 0, 0, 1, 1, 4, 2. And if you can, 9, 3, can I go out to 9? 1, 2, 3, 4, 5, 6, 7, 8. Not quite, but it would be somewhere out there. So it looks like this. So literally all you have to do the inverse is switch these. So this is the point 3, -2. So just like in example 1 where we reversed all these ordered pairs, I'm going to do the exact same thing. Now I'm going to do -2, 3. And you don't have to actually write them. I was just doing it for your notes. This is the point 4, -1. So now I need to do -1, 4. And I can already see that this one I'm not going to be able to do. This is going to be the point 7, 0. So I would need 0, 7. But you get the point. So watch this. The line y is equal to x is right here. Be careful not to go to the corner. Make sure you go to these spots that are 1, 1, 2, 2, 3, 3. If you look at that line and think about folding your paper along that black dashed line, the blue graph and the green graph would actually hit each other if you folded your paper. So fold here. This should be the line of symmetry. If it is the line of symmetry, then you know you did it right. And those are the 3 ways that we're going to study inverses today. Now, just like the x and the y values all switch, the domain and the range switch also. That's what this is saying. The domain of f of x is equal to the range of the inverse, and the range of f of x is equal to the domain of the inverse. So we're going to go back and look at these examples again, just so you can see. In this one, the original, the domain is 0, 3, and -1, the x values. Remember, domain is everything that x can be. And the range is 2, -4, and 5. But now for the inverse function, the domain is 2, -4, and 5. And the range is 0, 3, and -1. See how they switched? Let's do the same thing for number 2. In the original function for f of x, the domain is all real numbers. So you may recall that the only 2 things you have to watch out for domain are radicals and denominators. And this one does have a radical, but it's an odd radical. So you can take the odd root, the cube root specifically, in this case, of a negative number. So that's not a problem. It's only square roots, 4th roots, 6th roots that are a problem. And the range is all real numbers. So wasn't a very interesting one, because even if you switch them, the domain is still going to be all real numbers. We know that from a cubic graph. It just covers everything. And the range is all real numbers. So you can't even tell that they switched. But number 3 will be more interesting. So for number 3, look at this green graph. You don't even have to use the function. You can see that the x values start at 3 and they go to infinity, using interval notation this time. And the range, the lowest the y value ever is -2. And it goes up to infinity. Now, it doesn't look like it's reaching very high, but eventually, if you kept going, it would reach infinity. Now, for the blue graph, the inverse, for f inverse, the domain, now x actually starts at -2. And it may look like it never reaches 10, but if you kept going far enough, there would be an answer for that. But it starts at -2 and goes to infinity. And the range, which is all the y values, it never goes below 3. 3 is the lowest y value. So the range is from 3 to infinity. Notice that they switched. I told you domain and range going to keep coming up. Make sure you know it. Okay, so functions, I'm reading here, and their inverses undo each other. Think about all the inverses you already know. If you add 3, but then subtract 3, you've pretty much undone something. When you guys have an equation like this, how do you undo the times 3? You undo it by dividing. You've been doing inverses your whole life and never even thought about it. When you have a cube root, How did you undo it? With a cube. And notice what happens every time. If you start with x and you add 3 but then do the inverse, you're left with x. If you're multiplying by 3 but then divide by 3, what are you left with? X. If you have a cube root but then you cube it, what are you left with? X. So if you ever do composition of functions f of f inverse, you're going to get x. And if you have f inverse of f of x, you can do it the other way also, you're going to get x. We're going to use that fact to verify that two functions are inverses, meaning sometimes you have to find the inverse, but sometimes I'll give you the inverse and I'll just ask you to verify it. So for example 1, we are going to find the inverse, and then we're going to verify it algebraically using the composition of functions. And then we're going to verify it graphically, because remember, it should go right along the line y is equal to x. Okay, so first finding the inverse. The first step, if it's not already a y, you're going to have to make it into a y. And now step 1 is to switch x and y. I actually think I'm going to put it over here. So I switch x and y, so now I have x is equal to y minus 2 over 5. And then step 2 is going to be to get the y by itself. So your first goal is going to be to clear the fractions. So step 2, get y alone. Step 1, switch x and y. All right, so on step 2, now I have 5x is equal to, so the multiply by 5 undid the divide by 5, y minus 2. And now I have 5x plus 2 is equal to y. Step 3, don't forget, is to rewrite it back as an inverse. So my inverse function is 5x plus 2. That's what you would box if you were doing a test. That's the inverse. So now I'm going to verify it algebraically. That always means compose. So I'm going to stick f inverse inside f of x. This is the composition of functions that we learned last time. So I get something minus 2 over 5. What's going to go in that spot? F inverse. So it used to be x minus 2 over 5. I'm going to put my inverse right in there. 5x minus 2. Oops. 5x plus 2. There's a plus there. And what does that give me? The 2's cancel, and I get 5x over 5. And then the 5's cancel, and I get x. I've verified algebraically that it worked. Now I'm going to do it the other way. If I put f of x inside f inverse, it should work. So f inverse, always write the beginning, but leave the x out. So f inverse is 5 times something plus 2. What is that something going to be? F of x. That's what I'm going to put inside. So I'm going to put x minus 2 over 5 in that spot. Well, when I multiply by 5 and divide by 5, they cancel, and I just get x minus 2, and then I still have that plus 2, which leads me to x. So a little warning here. Sometimes I always write this on a quiz or a test, and it says verify algebraically that they're inverses by taking the composition. And what some kids do is they just do the inverse, and if it matches, then they, they say they did it. But I don't want you to do this. I want you to actually do the composition. Okay. Now we're going to do it algebraically. So we have two functions. We have f of x, which is x minus 2 over 5, and we have f inverse, which is 5x plus 2. And you should graph the line y is equal to x as a dashed line. So you could just make your dots and then you don't have to actually dash it. If your answer doesn't reflect over this, then you've done it wrong. So obviously the blue one's easier. I know you guys all want to do the blue one first. So with the blue one, it's going to start at 2, and then it's going to go up 5 and over 1. 1, 2, 3, 4, 5 over 1. I can't go any further, but I can go down 1, 2, 3, 4, 5, but then back 1. 1, 2, 3, 4, 5. So I can't even do any more lines in that, any more points. And now the green one. So the green one is a little bit harder because it's written like a fraction like that. So while it's still in this form, you should find one good point. And then you can see that the slope is 1/5. But please do not change it to x over 5 minus 2 over 5 and start at 2/5. It is such a bad way to graph a good line. So here's a little clue. If the point 0, 2 works on this one, then the point 2, 0 should work on my green one. So let's try that. So my good point should be very easy to find in this case. If x is 2, I get 0. And it has a slope of 1/5. So up 1 over 1, 2, 3, 4, 5. Can't do another one in that direction, so I'm going to go this way. Down 1 and back 5. 1, 2, 3, 4, 5. Down 1 and 1, 2, 3, 4, 5. So what do you think? Look, turn your head a little bit, tilt your head, and line up your head with the black line. If you folded it at the black line, would they match? Absolutely they would. Okay? So if you fold it along that black line, then they'll match perfectly. That's how you verify algebraically and graphically. So the next one is the exact same thing. So if you wanted to give yourself a chance to practice, you should stop the video, see if you can do this next one on your own, and then just fast forward. But I am going to do it out. So step 1 is to find the inverse. I change this to a y. I rewrite it as x is equal to y cubed plus 1. I subtract 1 from both sides. I take the cube root of both sides. And I have found my inverse. F inverse is the cube root of x minus 1. I feel pretty good about that. But now I'm going to verify it algebraically. That always means composition of functions. If you don't do composition of functions, you won't get credit. That's the only way to verify. So there's two parts. First is doing f of f inverse, and then doing f inverse of f. If they make x, then you've verified it. That's our goal. Okay, so the f function is something cubed plus 1. What goes in that something? F inverse, cube root of x minus 1. Now, please do not just go equals x, and not show me the steps. The whole point is you're verifying. So in the first step, you would sit there and say the cube and the cube root cancel and leave you with x minus 1. There's still a plus 1 there. That's equal to x. Now on the next one, the cube root of something minus 1. That's where the x usually is. So what goes in that something? The original function, x cubed plus 1. That's what composition is. When I put this, right, this is what goes inside the f function. This is what went inside the f function. Okay, so simplifying this inside, I get the cube root of x cubed because the 1 and the negative 1 cancel, and then that sure enough becomes x, and I verified it. Part B, verify graphically that you have the correct inverse. So I'm going to graph both of them. Remember that my original function, I'll make that in green, is x cubed plus 1. And then my blue function, f inverse, is going to be the cube root of x minus 1. Don't forget also to graph the line y is equal to x. You can just make it dashed. And you know you've done it right if it reflects. So I'm going to graph the green one first. It's easier for me. I know what the cube graph looks like, but I'm going to go up 1, and then that's my new 0, 0. And from there, the points that I'm thinking about should be just x cubed. Like I'm not worrying about the plus 1. So 0, 0, 1, 1, negative 1, negative 1. And if I can fit it, I try to do 2, 8, and even negative 2, negative 8. So here's my points, but it really does help from your new fake origin to go over 2 and then up 8. 1, 2, 3, 4, 5, 6, 7, 8. And from my new fake origin over 2 and down 8. 1, 2, 3, 4, 5, 6, 7, 8. Now there's 2 ways to proceed. You can graph the cube root function, or you can switch all these points and see if they come out to be the cube root function. So let's do that. So if I switch this is 0, 1, I'm going to do 1, 0. This is 1, 2, I'm going to do 2, 1. This is 2, what is that? 9, so I'm going to do 9, 2. This is negative 1, 0, so I'm going to do 0, negative 1. And this point is negative 2, negative 7, so I'm going to do negative 7, negative 2. So I know it reflects. I reflected all the points. So that's not really the test. Now the test is this a cube root function that has been moved over to the right one? You bet it is, because the normal, the original cube root function, is 0, 0, 1, 1, negative 1, negative 1, like that. So this one is to the right one. So in every way that you've been learning precalculus in every test, this totally works. I hope you're liking inverse functions. Not all functions have an inverse function. Remember that for an equation to be a function, it must pass the vertical line test. For a function to have an inverse function, it must pass the horizontal line test. If it does, the function is said to be a one-to-one function. That actual terminology is not that important to me, but it's in your book, and I didn't want you to say, oh, what's one-to-one? She never did that. So for each of the following, we're going to determine if it has an inverse function. If it does, then we're going to sketch both the function and its inverse. Then we're going to verify that they are inverses. And if there's no inverse function, then we're going to do something to make it so that it has one. So this time, let's just sketch this right away. I always am drawing my little y is equal to x line. This helps me know I did it right. So my new origin is going to be at 4, 0. So 1, 2, 3, 4, 0. And then from there, my square root numbers that I want you to have memorized are 0, 0, 1, 1, 4, 2. So 0, 0, 1, 1. I can't quite do 4, 2. So does this pass the horizontal line test? Yeah. You could draw a horizontal line anywhere, and it's only going to pass through one number. It looks like it starts to flatten out, but it's ever so slightly increasing. So it does have an inverse. We need to find that inverse. So I'm going to say that this is 4, 0. So now I can do 0, 4. This is 5, 1. I'm going to do 1, 5. I can't really do the next one, but I know the basic shape looks like that. So I've sketched both the function and the inverse. Now, there's two ways to find the inverse. You could do algebraically, which is what we've been doing, or you might recognize that. This is something new. Can you just look at that and say, oh, I know what that is? F inverse is, oh, it's half a parabola. Well, we'll get to that. It is a parabola that's been moved up 4. So if you're good at doing it that way, there's nothing wrong with that. If you're not good at that, then you would go back to the old way. Y is equal to the square root of x minus 4. Switch the x and the y. Square both sides. Add 4. That wasn't hard. Okay. So 2 different ways of doing it depending on your abilities. But this does have a domain restriction. It's not the whole parabola, because a square root is only half of a parabola. So you would have to say for x is equal to 0 to infinity. It doesn't keep going in the negative direction. It's only that piece of it in order to be correct. So the verification algebraically, you don't actually have to do both. I will let you do one or the other. It's a little bit annoying to do both of them. So let's just pick f of f inverse, and the next one I'll do the opposite way, because it doesn't really matter. So if I'm putting the f function in, then I go like this, and now I fill the inverse in right here. Remember, when you do this verification, it should come out to be x. But don't just write x. Show me each step that makes it x. So since the composition of the function and its inverse makes x, I have verified it. I've verified it graphically, algebraically, and I found the inverse graphically, verified it manually. So there we go. Again, you're welcome to stop and see if you can get these on your own. This is a parabola that's been moved up 1. No, sorry, down 1. But it's going up. So that's my new fake origin. So 0, 0, 1, 1, 2, 4. 1, 2, 3, 4. All parabolas. 0, 0, 1, 1, 2, 4 on both sides. 3, 9 if I could fit it, but I don't think I can. Okay. This does not pass the horizontal line test. So you can't make an inverse function. You can make an inverse. It would look like this. And then 1, 2, 3, 4, 2, 4, 2. So this is the inverse, but it's not a function. So it's not that there's not an inverse. There's not an inverse function. which is different. So I don't know if it's worth going. Yeah. So what we're going to do is we're going to restrict the domain in order that we can get the inverse function. So a little tricky. Here's how we're going to do it. So we're going to change the original. This sounds silly, but I want a different color. We're going to change the original. F of x is equal to x squared minus 1. And I'm going to say, you know what? Let's just draw that from 0 to infinity. Let's get rid of the symmetric part. That's how you can think of it. The part that has symmetry is the part that's also doubling it. So now that I've done it, now it passes the horizontal line test. So now that it passes the horizontal line test, now we can go ahead and graph that. So again, you can graph it just by reversing all the points. We have -1, 0, or sorry, 0, -1. So we're going to have -1, 0. And then 1, 0, 0, 1. This is the point 2, 3. So we're going to do 3, 2. And does that reflect? Absolutely it does. You still have to actually find the inverse. Maybe graphically you're really good at graphs and you say, oh, that's a square root curve that's been moved to the left 1. It's okay though if you're not good at that. If you're not good at it, then you can find it algebraically. This is the original. This would be the inverse. Solving for y. Y would be, now technically it would be plus or minus when you take the square root of something. So it's your job to realize that you really just want the plus part of the square root. So a square root function, that's the plus part and that's the minus part. But we just want the plus part. So this would be the inverse function, which, like I said, you might have found graphically. So you can find it graphically, or you can find it algebraically, or algebraically, whatever works for you. I'm trying to give you choices and show you a lot of different things. Obviously, we verified it graphically because it reflects over the line. If you can fold it along that, it should match. But the algebraic verification is to put one inside the other. This time I'm going to do F inside F inverse. So that means that I'm going to mostly write F inverse. And then right here, I'm going to put the original function, which is in green, x squared minus 1. That gives me the square root. Oh, what's wrong? Oh, there should be a plus there. Sorry, plus 1. So they do cancel. It is a plus 1. And that gives me x. And that's how you verify it. If when you do the composition in either direction, if it comes out to be x, then you know that you've done it correctly. So the key on this one was this whole thing about restricting the domain. You can restrict the domain to make the problem have an inverse. All right, let's do number 3 together. Or unless you want to try it on your own, great. You can come back and see if you got it right at the end. So this time I'm going to go straight for the algebra. Y is equal to, because I've done the last 2 graphically, and I want you to see that if you're not good at graphing, algebra will work. I switch the x and the y. I cube both sides. Let me show that. Cube is equal to y plus 1. And I get x cubed minus 1 is equal to y. So the original problem, at some point you are going to have to graph it. Let me just write this as inverse first. So I have my inverse and I have my original. Let's do it in a different color. So the original is a cube root function that's been moved to the left one. So if that's my 0, 0, 1, 1, negative 1, negative 1, and then 8, I don't think I can quite make it. 1, 2, 3, 4, 5, 6, 7, 8, 2. I'm only doing just a little bit like that because I just think it helps you make a nice shape, even though it's kind of off the graph. The blue one is a cubic graph that's been moved down 1. That's my new 0, 0. Those are my points, and from my 0, 0 over 2 and up 8. 1, 2, 3, 4, 5, 6, 7, 8. So it looks something like this. Have I verified it? Graphically, I have, if it reflects over this line, then I can feel good about it. Yeah, it's not perfect. Pretty close. That's the graphical verification. For the algebraic verification, you can do it either way. I do not require you to do both. We did F inverse last time, so let's do F of F inverse this time. So that means I'm going to write F, and then I'm going to put F inverse inside of it. So my blue F inverse, x cubed minus 1, is going to go right in there. That gives me the cube root of x cubed, which is x. Whenever this comes out to be x, I know I've done it correctly. This one did not require a restriction of the domain because it passed the horizontal line test, which most of them are going to. So if I draw a horizontal, so remember the original was the red, if I draw a horizontal line, it only hits 1 point. So it passed the horizontal line test, so it's pretty much business as usual. Again, you might want to try this one on your own and make sure that you can get it. It asks you to sketch it. So this is the function y is equal to 5 minus 3x over 2. I'm always telling people that I really do not want you to switch this to negative 3 halves x plus 5x, 5 over 2. That's great for slope, but please don't use this b. Okay, I need accurate points, especially on here where you're reversing the points. Instead, from here, find one good point. It might take you just a second. You might think, oh, if I plug in 0, I get 5 over 2. That's not a good point. If I plug in 1, 5 minus 3 is 2. 2 over 2 is 1. There you go. Spotted. So easy. Okay, always find a good point. And now that I have a good point, now I can do down 3 and over 2, down 3 and over 2, up 3 and back 2, up 3 and back 2. Okay. Let's do the inverse in blue. So on the inverse, I'm going to switch x and y. X is equal to 5 minus 3y over 2. Some of you are choosing to do it graphically. That's okay. Multiply both sides by 2 to clear the fractions. That gives me 2x is equal to 5 minus 3y. So I don't have to divide by a negative. I'm actually going to move the 3y to this side and the 2x to that side. I'm trying to get it into a format that I really like. I divide both sides by 3. And you probably don't want to switch it to this. I'm not saying you can't, but again, I wouldn't bother. I would just leave it here because all you need is one good point. So my F inverse is negative 2x plus 5 over 3. So I have an original function and I have an inverse. Let's graph this inverse. So this is really nice. Remember what I said about needing one good point? You can just switch any good point from the other one. So 1, 1 will work. For that matter, 3, 2, or 3, negative 2, you can do negative 2, 3. And sure enough, if you try any of those, if you plug those in, they do work. Negative 2 times negative 2 is 4. 4 plus 5 is 9. 9 over 3 is 3. So we've already got a couple good points. Negative 2, 3, 1, 1. And from there, I would use slope. Down 2 over 3. Can't go further than that. Up 2, back 3. So the reason I wanted to do this one is this is actually pretty hard for kids to see its reflection without actually drawing the line y is equal to x. And even then, it can be a little bit tough. Not all of them are going to be, the curves are actually easier, to see how they reflect. But tilt your head so that your head's in line with this diagonal, and then try and picture yourself folding it. If you folded it, this blue would match this red, and this red would match this blue. So it does work out. Last step, we're going to verify algebraically. It doesn't matter which way you do it. I'm going to put F inside F inverse. So that means I write F inverse, negative 2 times something plus 5 all over 3. And what goes in there? The original. So 5 minus 3x over 2. So when I do that, the 2's cancel, but it does leave a negative. So you're going to get negative 10 plus 6x plus 5 over 3. So you have to distribute. Oh, sorry, the 2's gone. Oops. You're just going to get the negative, not the 2. So the 2's gone, but you're still going to get the negative. So minus 5 plus 3x plus 5 all over 3. The negative 5 and the negative 5 cancel, and then you just get x. Whenever the inverse and the regular and the original function are composed and you get x, then you've verified it algebraically. Almost done. Just a summary and some challenge problems. So I've written just down some notes to help make sure that you've got it all. I don't know if it helped or not, but you can read through those on your own. There are 2 challenge problems here. They are not required. It really is just that sometimes people get inverses really well, and this is just to kind of give you a little bit of a stretch. So I'm going to give you the 2 answers, and if you would like to try them on your own, then I think that would be really great, but I'm not going to force you to. X plus 9 over 2. Okay, you do have homework, and this is the end of the chapter. If you haven't been making a reference sheet for all your quizzes, make sure you do it now. You're allowed an appendix. You're going to want it. It's going to be a big test. It's going to have a lot on it. When you come into class, you'll take that test right away, and you'll have the whole 55 minutes to do it, and it'll cover the whole chapter. So make sure that you have a reference sheet that has no actual examples on it, but whatever kind of notes you want. There is a chapter review for you to do. I have thought about this and I can't find a way around it. You guys can't take your test on the same day. So one class will, because half of you are virtual. So one day the in-class kids will take the test and the virtual kids will have an extra day to study. I know, so unfair. And then the next class, the class that already took the test, has a chance to get ahead on their homework for the next section. They can just start doing chapter 2. I will make sure that whichever way it was, the next way it flips. So the virtual kids or whoever, one group is getting the benefit of an extra day to study before their test. And I apologize, but it can't be helped. So that's the end of this lesson and the end of this chapter. Have a great day.